Okay, so our next topic is ancient Greek, or continuation with ancient Greek philosophers and astronomy. Okay, so learning outcome: write a summary of ancient Greek two-domain view, tabulate of the different material elements in motion according to the two domains view. List the naked eye astronomical proofs that the earth is round or spherical. So, ganun pa rin yung learning outcome natin. So, outline is ancient Greek philosophers and astronomy. So, let us start with ancient Greek philosophers. Okay. So, we have Pythagoras, Plato, Eudoxus, Aristotle. So, we have 4 and then the divided line. Let's start with Pythagoras. Okay. Pythagoras, 570 to 495 BC. Universe is mathematical, according to him. Mathematics is the best way to express truth about the universe. Sun, moon, and earth are spherical. Place earth as the center of the universe. So, according to Pythagoras, ang sentro ng universo or ng Milky Way is yung earth instead of the sun. Okay, so now let us go to YouTube and add some more details regarding to Pythagoras and his theory. Okay, so YouTube. Okay, Pythagoras. Earth is the middle or is the center of the universe. Okay. So maybe let's start with this one. Earth is the center of the universe, or the earth. How we came to realize that the earth was at the center of the universe. Let's prove that the earth was round. Okay. Okay, dito lang tayo sa this one.
Wind, show me where to go.
Knowledge of the Earth's spherical shape is nothing new. Well, at least for most of us, that is. You might even be surprised to learn that the Earth's shape was discovered over 2,000 years ago, well before any advanced satellites were able to make the exact measurements that we have today. To be fair, many of the ancient civilizations likely assumed that the Earth was round even before having the evidence. The first credited to propose such an idea was philosopher and mathematician Pythagoras back in 500 BC. But when it came to proving that the Earth is round, it wasn't until Aristotle came around that hard evidence was first laid out. When Aristotle wrote his book On the Heavens in 350 BC, he laid out several pieces of evidence for why he believed the Earth assumed a spherical shape. One thing he noticed and pointed out was that each time there was a lunar eclipse, the shadow of the Earth upon the moon could be seen. And since that shadow is always round regardless where the Earth is in its rotation, the Earth must be round as well. Another point he made was that the stars are constantly in different positions depending on where you are on the Earth. Aristotle noticed that there were stars that he could see in Egypt that could not be seen from Cyprus, some 1,000 kilometers away, and that as you move further and further away from the equator, the visible constellations in the sky would dramatically change. That proved, as he wrote, that not only that the Earth is circular in shape, but also that it is a sphere of no great size, for otherwise the effect of so slight a change of place would not be quickly apparent. Several years later, another Greek scholar, Eratosthenes, would go a step further and not only prove that the Earth was round, but also measure its circumference with only the power of the sun and a stick. Known as one of the most prominent scholars of his time, Eratosthenes studied in Athens and produced impressive works in astronomy, mathematics, geography, and philosophy. In 240 BC, he was even appointed as the chief librarian of the Great Library of Alexandria, one of the largest and most significant libraries of the ancient world. One of Eratosthenes' many ambitions was to create a world map, and to do that, he knew that he first needed to determine the size of the Earth. Eratosthenes lived in the city of Alexandria, near the mouth of the Nile River in present-day modern Egypt. He had first heard about a well located in the ancient city of Syene, which is now present-day modern Aswan. He realized that at noon on the summer solstice, when the sun was directly overhead, sunlight illuminated the entire bottom portion of the well, without casting any shadows on the sides, like during other days of the year. He then checked to see if the same phenomenon was happening in Alexandria by placing a stick upright in the ground at noon on the day of the summer solstice. Here, he noticed that the sun did cast a shadow at an angle of 7.2 degrees. This is because the city of Alexandria is north of the Tropic of Cancer, or also known as the northernmost point where the sun will be directly overhead. Eratosthenes realized that he could then perform some simple calculations with this measurement and easily determine the circumference of the Earth. However, one important factor in this calculation was determining the distance between Alexandria and Syene. With modern technology, this would be no big deal, but back in 240 BC, this was much more difficult to perform and especially perform accurately. Eratosthenes hired what was known as a bemetus, who essentially was a professional walker trained to measure distances by counting steps. Although not much is known about their measurement methods, they were known to have a high degree of precision and were thought to have accompanied Alexander the Great on his campaign throughout Asia. These bemetus, which measured distances and length of stadia, an ancient Greek unit of length based on the circumference of a typical sports stadium, determined that the distance between Alexandria and Syene was roughly 5,000 stadia, or 800 kilometers in today's terms. Since Eratosthenes knew that the sun hit straight on in Syene and at a 7.2 degree angle in Alexandria, the distance between them should be a 7.2 degree piece of the 360 degree sphere that is the Earth. Conveniently, 7.2 degrees is 1/50th of a full circle, meaning that the distance from Alexandria to Syene equates to roughly 2% of the total Earth's surface. By taking this estimated distance of 800 kilometers and multiplying it by 50, he was able to determine that the Earth has a total polar circumference of roughly 40,000 kilometers. So was he right? Well, he was really close. Today, we know the Earth has a circumference of 40,075 kilometers around its equator, and 40,008 kilometers when measuring the polar circumference. This is due to the slight bulge that the Earth has around its middle due to the spin of the Earth. It is important to remember as well that he had to make many important assumptions which at the time were not so accurate. Number one, that the distance between Alexandria and Syene was exactly 5,000 stadia, or 800 kilometers. We know today that this distance is measured at 841 kilometers. Number two, he assumed that Alexandria is due north of Syene, which although it is north, it is not directly due north as he originally assumed. Number three, he assumed that Syene lies on the Tropic of Cancer. Today, we know that present-day Aswan is actually 73 kilometers away from the Tropic of Cancer. Number four, that light rays emanating from the sun are parallel. And finally, that the Earth is perfectly spherical in shape. With proper measurement tools and accurate distance measurements between Alexandria and Syene, Eratosthenes would have likely been able to get a much closer result. In fact, in 2012, a similar experiment was conducted with more accurate measuring tools, and it was calculated that the distance was 40,074 kilometers, which is only 0.16% off from the currently accepted polar circumference of the Earth. It is certainly amazing to know what was accomplished so long ago with such a limited tool set. Today, with advanced satellite measurement capability, we are able to determine the exact circumference down to the meter. Eratosthenes would go on to create his map as well as make many other breakthroughs, but that will have to be saved for another video. If you would like to stay updated with more videos like this one, be sure to click on the subscribe button below. And as always, thank you so much for watching this video.
Okay, so yun yung mga early Greek philosophers, starting with Pythagoras, na sinasabi ni Pythagoras na ito si Pythagoras na ang center ng universe ay yung Earth, but came Aristotle, okay, na sinasabi naman ni Aristotle na possibly ang Earth po ay round or sphere, na possibly ang center ng universe ay hindi Earth, no? Although hindi niya sinabi na sun iyon, pero meron siyang propositions na ang Earth ay hindi center ng universe because of some eclipses or lunar eclipse, pati yung mga shadows, ano, at yung mga stars, no? From one area, let's say sa Athens, nakikita niyo yung star, yung mga placing ng stars. Pagdating sa Syene o sa ibang lugar, iba yung placing ng mga stars, okay? And then come Eratosthenes, kumbaga dinagdagan niya yung sinabi ni Aristotle na yung Earth ay hindi po center ng universe, tapos ang Earth po ay sphere or round, because doon sa kanyang mga experiments, like yung stick, pati yung sinag ng araw, pagka noon, ito yung position ng shadow. Pagdating ng mga 5, ito yung position ng shadow. So, yun. Doon siya nag-ano ng conclusion. And, he do some experiments, nag-hire siya ng mga professional workers para ma-estimate yung distansya ng Athens through Syene, para magkaroon siya ng medyo accurate na calculation regarding sa theory niya na Earth ay sphere or round. Okay, so let's continue with our manual or reference. So we have Plato here, 427 to 347 BC. Attainment of perfection as absence of change. Okay, mathematical symmetries to demonstrate perfect shapes, like a sphere and circle. Celestial spheres being crystalline and contains the moon, the sun, and the stars, explaining the shadows. So, yan, makikita yun sa allegory ni Plato. Dun sa allegory of the cave and the allegory of the shadows. Okay. So, si Plato po yung propose dun sa study ng universe using yung moon, yung sun, and then yung stars. Okay. Then we have this divided line as his description ni Plato or framework on how to look at the universe using yung moon, sun, and stars. In particular, that the daily and annual patterns of the sky must have a greater regularity besides its appearance. So, ganun din, so aside from observing yung moon, sun, and stars, Plato also observed the universe through daily movements ng sun, moon, and stars, and yung yearly or annual na movement ng ating heavens or sky. Okay, yung appearance ng, again, moon, sun, and stars. Okay, then we have Eudoxus, followed previous models of the universe but added auxiliary spheres to provide appropriate tilt to the planet's path. So si Eudoxus naman yung nagdagdag ng tilting ng moon, ng Earth, no? Pati ng Sun. Sinasabing ni Eudoxus na umiikot tong moon, umiikot din itong Earth natin, kaya nagkakaroon ng iba't ibang panahon dito sa atin dahil umiikot siya dahil dun sa tinatawag na sphere, okay? Auxiliary sphere, okay? So that's Eudoxus. When we look at the dito sa YouTube, hindi natin papanoorin ng buo kasi because of the time. Tilting sphere, and then Eudoxus. Okay, ito description of Eudoxus and Nicholas Copernicus. We have retrograde motion and circles. Sige, play na natin. Total 4 minutes lang naman. Let's listen. Siguro okay na yan. Okay. So, yun nga, yung sphere na sinasabi ni Eratosthenes, ano? Kumbaga, may invisible na sphere na dinadaanan yung ating Earth, and yung ating Moon, saka yung ibang planets na, ano po. Okay. Medyo humina ang aking internet connection. Try ko itong isa. Okay, next, habang nagkoconnect ako sa internet, let's go to the other one. Okay, we have Aristotle, two-domain system with terrestrial domain, containing four elements that tries to attain perfection by being in their natural location relative to the center of the universe. The center of the Earth, okay, sa atin yan, sa universe. He was a learner of Plato. So, although may mga notion si Aristotle na hindi ang Earth ang center ng universe, ano pa rin siya din, ano? He still proposes that Earth is the center of the universe. And then, he also introduces yung four elements dito sa Earth, ano? Namely, we have yung Earth, wind, fire, and then water, no? Being the most important elements that we could find here in our planet. Okay, next to this early Greek philosophers regarding our universe, we have yung domains, ano, yung dalawang domain ng universe according to this Greek philosophers na to, ano. So we have yung terrestrial domain and celestial domain. Elements under terrestrial domain, we have fire, air, water, and earth. Celestial domain, we have either motion, we have alteration, natural motion, violent motion. Celestial, we have perfect motion, circular, and constant speed. Yung pinanood natin kanina kay Eratosthenes, ano, that is celestial domain. So, may perfect motion. Okay. Tapos itong kay Aristotle, yung terrestrial domain, ano, including sa fire, air, water, and earth. Okay. So, let us read yung description sila. According to them, the universe is divided into two domains, terrestrial and celestial. The celestial domain is perfect, hence can only be made up of the perfect substance they call the ether, and can only move in perfect motion, circular path, and constant in speed. The terrestrial domain objects are imperfect, and that the tendency of things to attain perfection is the cause of their motion. Okay. Meanwhile, they also believe that things depending on their composition of the elements, fire, air, water, and earth, tend to move towards the center of the universe or away from it with earth. Okay. Naturally, as at the center. Fire and water naturally move away from the center. Okay. Kumbaga, no, fire and water, they contrast, they move away from the center. Then yung air tapos yung earth hindi naman, ano, are going near the center. Based on the notion of how the universe is made up and the tendency of things to move towards their perfection, natural motions believe us that they bring things towards their more perfect state, no? Thus heavy objects fall faster than lighter ones. Even so, they also know the effect of air drag being related to medium density as well as the mass of the object. The notion of falling faster may be close to terminal speed than the concept of acceleration. So, mas mabilis na bumagsak yung mas mabibigat kasi they near perfection compared to yung magagaang, ano, yung lighter objects. But we also know, kaya mas mabilis yung mas mabigat bumagsak dahil doon sa, ano, no, law of gravity, no? Ayan. Because of their weight. Hindi yung object is near perfection, kumbaga. And then we have this diurnal motion of the sky and annual motion. Under diurnal, the appearance of the objects is in the sky moves relative to the Earth's local horizon. Celestial objects, moon, sun, stars, planets. Kumbaga, and then there were only 5 known planets before, okay, especially on the early Greek philosophers' days, we have only Mercury, Venus, Mars, Jupiter, Saturn. They as observed for one whole day at the same location on Earth. While we have annual motion of the sky for a while. Pause muna natin to. Okay. The appearance of the objects in the sky moves relative to the background stars as observed at the same time the day and the same location on Earth. So that is annual and diurnal motion of the sky. So let us have one more video regarding this terrestrial and celestial and diurnal and annual. Siguro diurnal and annual na lang tayo. Diurnal and annual. Okay. Motion of the sky. For a while, lag pa rin hindi pa rin siya napunta-maayos. Ayan, umulat siya. Okay, so medyo mabagal pa rin. This is 5:01, so ito na lang tayo. For a while lang, class. Medyo mabagal ang internet ko. Hintay natin siya mag-load. Kung sa bako ito. Balik ko ng bako. Saan may internet ka, no? Ano yung ulit sa ilan yun? Ano ka na? Then ano po, hindi po naputol yung connection lang. For a while lang, class, connect lang tayo sa internet. I believe may connection na ako, so start natin to. Okay. Okay, yan na, plus.
Sa pananaw ng mga sinaunang Griego, mayroong dalawang uri ng motion o paggalaw. Ang mga ito ay walang kinalaman sa isa't isa. Ito ay ang terrestrial motion at ang celestial motion. Ang talakayang ito ay nakatuon tungkol sa celestial motion. Tatalakayin natin ang terrestrial motion sa mga susunod na talakayan. Ayon kay Aristotle, ang celestial motion ay walang katapusan at walang anumang dahilan para mangyari ang paggalaw ng mga bagay sa kalangitan. Isa na rito ang diurnal motion. mayroon tayong tinatawag na pagsikat at paglubog ng araw. Naniniwalaan ng marami na ang araw ay sumisikat mula sa silangan at lumulubog naman sa kanluran. Pero sa totoo lang, wala naman talagang sunrise o sunset. Ang mga nakatuklas nito ay hindi mga scientist. Sila ay mga sinaunang Greek philosopher. Ang diurnal motion ay pinaliwanag nila gamit ang kanilang obserbasyon at lohika. Wala silang mga modernong kagamitan o kasangkapan para obserbahan ang mga ito. Ayon sa kanila, ang sunrise at sunset ay sanhi ng pag-imog ng mundo sa kanyang axis. Naobserbahan nila na hindi lamang ang araw ang sumisikat sa silangan at lumulubog sa kanluran, maging ang buwan at mga stars o bituin ay ganoon din. At nakita nila na paarko ang kilos ng mga bituin sa kalangitan. Gamit ang lohika, senyalis daw ito na hindi ang araw at mga bituin ang gumagalaw, kundi ang mundo mismo ang umiikot sa axis. Sa ngayon, may mga modernong kagamitan ang mga scientists, kaya nakukuhanan na natin ng imahe yung sinasabi ng mga sinaunang Griego na paarko o paikot ang paggalaw ng mga bituin sa kalangitan. Mayroon na tayong mga kagamitan na kayang i-trace ang paggalaw ng mga bituin. Ang araw-araw na paggalaw ng mundo at mga bagay sa kalangitan ay tinatawag nating diurnal motion. Mayroon tayong umaga at gabi. Nakikita natin na ang araw ay sumisikat mula sa silangan at lumulubog naman sa kanluran. Pero ayon sa mga sinaunang Grego, ang pag-ikot ng mundo sa kanyang axis ay mula sa kanluran papuntang silangan. Kaya ang naobserbahan natin ay baliktad. Sumisikat ang araw sa silangan at lumulubog naman sa kanluran. Ang isa pang celestial motion na naobserbahan ng mga sinaunang Grego ay ang annual motion. Nakita nila na ang mundo ay hindi lamang umiikot sa kanyang axis, ito ay umiinog rin paikot sa araw. Ang buong pag-ikot ng mundo sa araw ay tinatawag nating 1 year o isang taon. Natagpuan na mayroong 365 days ang inaabot ng mundo para makaikot ito ng isang paikot sa araw. At ang mundo ay umiikot sa tinatawag na orbit. Ngunit ang pagkakaroon ng tag-araw, taglagas, taglamig at tagsibol o yung tinatawag na 4 seasons ay dahil nakatagilid ang axis ng mundo, at ang pagkatagilid ng axis ng mundo ay dahilan din ng tinatawag nating precession of equinox. At yan ang ating tatalakayin sa susunod nating talakayan. Maraming salamat at hanggang sa muli.
Okay, yan na yung last video natin regarding sa diurnal motion saka annual motion. So, isang pagkaklaro lang diurnal motion, ito yung pag-ikot ng mundo natin 24 hours within the day. Kaya may umaga at may gabi, yung pag-ikot ng Earth sa kanyang axis, Okay? Ngayon, meron tayong annual motion. Ito naman yung pag-ikot ng mundo sa araw, sa loob ng isang taon. 365 days estimated. Okay? So, yung pag-ikot ng Earth is diurnal motion, at ang pag-ikot niya ay dahil sa axis sa tinatawag, axis. Yung annual motion naman, isang taon siya, at ang pag-ikot ng mundo sa araw, tinatawag, umikot siya sa orbit, hindi naman axis, orbit naman, okay? Meron siyang inikotan ng orbit sa annual motion ng Earth. Tapos sa diurnal motion naman, umikot siya doon naman sa kanyang axis, so magkaiba yung axis sa orbit, yung axis sa Earth, yung orbit, yung Earth doon sa araw. Okay? I hope na naintindihan po yun. So, that's it for now, regarding sa journal motion and annual motion na theory. And then, together with celestial domain ng universe, study of the universe. Pag sinabi natin celestial, yung observation ng moon, stars, and yung sa sun. Yung terrestrial naman, yung study ng universe based sa observation through geographical locations from one place to another. Okay? That's all for now. Thank you.